Bright Tuty. Every student matters.
Hello students, the name of this topic is contact forces. Till now we have understood that a force is a push or a pull, right? So for pushing or pulling you require some contact in many cases, right? So whenever there is the necessity of contact for a force to come into action, those forces are known as contact forces. Any forces that require contact between two objects are called as any forces that require contact between the two objects to come into action is called as contact forces, right? So two of these forces are muscular force and friction. Both these forces require contact between minimum two objects, right? So let us start with the first one being muscular force. Now students, muscular force is the force applied by our muscles. That our muscles produce, right? Any force that we utilize our muscles to come into action, right? Those forces are known as muscular force. Now let us see some examples. Here is a boy and he is carrying some books. So he is utilizing his muscular power to lift these books up, right? He is lifting. He is carrying, basically he is also walking by holding these books, right? Now walking. Walking is basically coming into motion. This is also muscular force because your legs are working in walking. So this is also muscular. And what is the contact? Let us see the contact factor in both the cases. The boy is holding the books. The books and the boy are in contact. That is how the boy is able to pick up the books, right? Because he is holding them. There is a contact between both of them. So that is how this case is of contact and it is muscular, right? Now the second case, the boy is in contact with the road. So due to the muscular force applied on the ground, the boy is able to walk, right? Then lifting weight. For lifting weight, this boy is holding the rod carrying the weights, right? And how is this happening? The boy is holding the rod with his two hands and the hands are in contact with the rod. So this is also a contact force, right? And he is using the muscular force to lift these up. So this is muscular force, right? Then when you pick a bucket, you are pulling it, right? You are picking it. So here also your hand is applying some force and there is contact between you and the bucket. So this is also an example of muscular force and which is also a contact force. Now coming to this picture, here you see a donkey carrying huge weights in different areas. We use many animals to carry our weights and this is only possible due to the muscular force of this animal. He is utilizing his muscles to produce some force due to which he is able to carry these objects. And this is again a contact force, right? So these were the examples of muscular force being a contact force, right? Now second topic is friction, the second kind of force. What is friction? Whenever the force that takes place, basically this is a box kept on the ground, right? So if you look very carefully, you will be studying this in the 12th chapter, which is friction. The contact of box and the surface of box and the surface of road are in contact, right? Every smooth surface has some rough basically if a surface appears smooth to you, then also it has some rough part on it, right? So these rough parts of the surfaces lock into each other, right? And when they are locked and you try to pull the box, right? You are trying to pull the box, but due to this interaction between the box and the ground, the box is not able to move. So this force that is produced due to the contact of two surfaces is called as friction. And friction basically depends on many factors. First of all, the factor is the smoothness of any substance, right? For example, if you are walking on grass, there is first case you are walking on grass, and the second case you are walking on marble. You will be slipping on marble and you will be walking comfortably on grass. Why is that so? Because grass has very rough surface and your body, your shoe's sole and grass interlock very good. So that is how you are not able to slip. You are walking comfortably. But marble is very smooth. So due to that smoothness, the friction is reduced and that is why you are slipping. Taking this example, picture A and picture B, this boy is skiing, right, on ice. Now ice is very smooth, right, and he is using these blades to ski. These ski blades also have very smooth surface. So the friction here is very less and that is why this boy is able to slide, right. But in the case of picture B, the surface is of grass and the boy is not wearing any ski blades, he is wearing socks only, not even shoes. So there is high friction and that is why this boy is not sliding, right. So this is again an example of contact force which is happening due to the contact of two surfaces, right. So this is the second example, which is friction. The two contact forces we talked about are muscular force and frictional force, right. Non-contact forces. Till now you have understood contact forces, which was muscular force and friction, in which contact was necessary, right. Without contact, those forces could not come into action. But these three forces are non-contact forces, basically magnetic force, electrostatic force and gravitational force come into action without contact between two or any objects. They do not require contact for their action, right. So the first kind of non-contact force is magnetic force. What is magnetic force? Basically, students, you have studied about magnets in class 6th in chapter 13, right? Fun with magnets. You already know that like poles repel each other, right? And unlike poles attract each other, right? We already know the rule that unlike poles attract each other and like poles repel each other, right? So what happens when you bring like poles near each other? They will attract, right? So let us perform an activity. You have to take two magnets. You have to put one magnet on three pencils, like in this picture, right? You have put this magnet on three pencils. Now you bring another magnet and you bring unlike poles close to each other. Unlike poles close to each other, right? As you can see, this is the north pole of this magnet and this is the south pole of this magnet, and you have brought them closer. So what will happen? You just have put one magnet in front of this magnet which was on the pencils. You will see that due to attraction, the magnet starts coming towards this magnet. Because the unlike poles are closer to each other, this magnet will start moving towards this magnet, right? Because they are attracting each other. So due to this attraction, this magnet came into motion, right? But was there any physical contact between them? No. There was no contact, right? You did not touch the magnets with each other. You just brought them closer and you brought unlike poles close to each other. So that is how the magnet which was put on pencils started moving towards the first magnet, right? And these pencils acted like wheels, right? These pencils acted like wheels. They started rotating as soon as the magnet came into motion. So due to this attractive force, the magnet came into motion, and this is magnetic force, right? And we just saw the case of two magnets. We can also put any iron article here as well. If you put an iron rod here instead of the magnet, that rod will also get attracted and that will also come into motion, right? Now taking the case 2. This is the case 2. In this case, you have put the magnet, right? You have put the magnet in opposite direction now. This south pole of this magnet is here and south pole of this magnet was already here, right? This is in the same position. We have reversed the position of this magnet. Basically, this was the magnet kept on the pencil. First of all, you brought the second magnet from this side. There were unlike poles, they got attracted. But then you brought this magnet from this side. There were like poles, so they repel each other, right? Due to the presence of like poles close to each other, right? Because like poles were close to each other, they started repelling and the magnet moved into opposite direction. It moved in opposite direction. Pencils again acted like wheels and it moved in another direction. So here also, due to magnetic force, due to repulsion, the magnet came into motion, right? So magnetic force is a force that does not require any contact to come in action. So this is a non-contact force, right? So this is a non-contact force, and in this force there is no necessity of any contact, and magnets attract and repel each other without contacting each other, right? Next question, next kind of force is electrostatic force, right? Let us study about it. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force, right? Let us see what happens here. Then we will come back to the statement. You have to take a straw. You will cut it into half, right? You suspend this one straw from the table, right? One part you suspend from the table. The other part, you rub this with a sheet of paper, right? You rub this part with a sheet of paper, right? You rub it with a sheet of paper. So this part that you have rubbed is now charged, right? You rubbed the second part and you basically charged it. Now you brought this charged straw close to the uncharged part of the straw, right? You will see that these straws attract each other. They attract each other. Now without any contact, you just brought them close and this straw started moving towards the charged straw, right? It was in rest at this position, but then it moved towards the charged body. So here you saw the force was exerted by a charged body on another uncharged body, right? So this is electrostatic force. Now what you have to do is, now you have to charge both the straws. Yes, the second case, both straws are rubbed with sheet of paper. With paper you can say. You have rubbed both the parts of the straw. Now what happens? Both of them are charged. And now, this is the second case. Now this is the first part of the straw and you are bringing second part of the straw close to it, right? Both of them are charged. Now what you will see is this straw will move away from the charged straw, right? There will be a repulsion when both of the bodies are charged, right? So what made this straw move away? The force exerted by a charged body on another charged body is known as electrostatic force. So in both the cases we saw that due to electrostatic force, the straw moved either towards the charged straw or away from the charged straw, right? Now this is because of electrostatic force. This force comes into play even when the bodies are not in contact. Here, in both the cases, we did not make any contact between both the straws. In both the cases, we never touched one straw with the another. We just brought one straw close to the other. In the case when the first straw was charged and the suspended straw, this is the suspended straw, and it was not charged, so it came closer to the charged straw because there was attraction and only one body was charged, right? Now in the second case, both of them are charged. This one is also charged, this one is also charged. You bring this charged body near another charged body, then you see there is a repulsion. It moves away from the charged straw because it is also charged. They carry the same charge, so there is repulsion. So this movement happened due to the electrostatic force. And here also there is no contact, so this is also a non-contact force. Alright, this was very simple. Till now we have studied two kinds of non-contact forces. The first one was magnetic, second is electrostatic. Coming to the third, it is again very interesting. The third one is gravitational force. Let us see what happens here. Objects or things fall towards the earth. Any object which is kept here, if I leave it freely, if I suspend it, it will automatically fall downwards, right? Now how is this happening? This is happening because earth pulls them. Our planet is pulling things towards itself. This force is called force of gravity, or just gravity you can say. This is an attractive force. This is an attractive force. The earth attracts all the objects toward itself. The force of gravity acts on all objects. Everything existing in this universe is experiencing this gravity. Every object falls towards the earth itself. And this force of attraction is known as force of gravity or just gravity. Now taking this simple example, you are pulling a bucket, right? This is the bucket and this is your hand. You are utilizing your muscular force to pick this bucket, right? But what is making it difficult for you to pick it up? It is the gravitational force, because the earth is attracting it towards itself. That is why it is difficult for you to pull up this bucket, because gravitational force is making some interaction in this action and it is not allowing you to comfortably pick it up, because it is opposing, because gravitational force is in this direction and your muscular force is in this direction. So you will be able to pick this bucket up when your muscular force will be more than the gravity acting on the bucket, right? It will only be picked up when your muscular force will be higher or larger than the gravity acting on the bucket, right? Now, these were the three kinds of non-contact forces that we had to talk about, right? Also, students, the planets existing in the solar system, the stars and the planet, also have a kind of gravitational force between them, and it is basically a theory that all the objects present around you exert some kind of attractive force on the other body. It is very least. It does not have a good magnitude, but yes, every body attracts another body. But basically that you do not have to understand at this age. You will be studying about this in class 11th and 12th. But here you only have to understand that Earth attracts everything towards it, and it is known as force of gravity or just gravity. Right? So we studied about three kinds of non-contact forces. First one was magnetic, second was electrostatic, and the third one is gravitational. Alright, this was all in this topic. Thank you for your attention, students.